Our group have chosen Colpitt's oscillator. So what is Colpitt's oscillator? Oscillator is an amplifier with the positive feedback, and it converts DC input signal into AC output waveform with certain variable frequency drive and certain shape of output waveform like sine wave or square wave or etc. by using the positive feedback instead of input signal. Oscillators which utilize the inductor and capacitor in their circuit are called as LC oscillator, which is a type of linear oscillator. LC oscillators can be designed by using different methods. The well-known LC oscillators are Hartley oscillator and Colpitt's oscillator. Among these two, the frequently used design is Colpitt's oscillator, designed by and named after an American engineer, Edwin H. Colpitts, in 1918. The Colpitts oscillator theory. It consists of tank circuit, which is LC resonance sub-circuit made of two series capacitors connected in parallel to an inductor, and frequency of oscillations can be determined by using the values of this capacitor and inductor of the tank circuit. The oscillator is almost similar to Hartley oscillator in all aspects. Hence, it is termed as electrical dual of Hartley oscillator and is designed for the generation of highly frequency sinusoidal oscillations, which the radio frequencies typically ranging from 10 kHz to 300 MHz. The major difference between these two oscillators is that it uses tapped capacitance, where the Hartley oscillator used tapped inductance. This is an example of Colpitt's oscillator circuit. It can be realized by using gain device such as bipolar junction transistor or BJT, operational amplifier, and field effect transistor or FET, as similar in other LC oscillators also. The capacitors C1 and C2 forms potential divider, and this tapped capacitance in the tank circuit can be used as the source for feedback, and this setup can use to provide better frequency stability compared to Hartley oscillator, in which tapped inductance is used for feedback setup. RE, or the resistor emitter, in this circuit provides stabilization for circuit against variations in temperature. The capacitor CE, or the capacitor emitter, connected in the circuit, which is parallel in the RE, provide low reactive path to the amplified AC signal, acting as bypass capacitor. The resistor 1 and resistor 2 from voltage divider from circuit and provides bias to the transistor. The circuit consists of RC coupled amplifier with common emitter configuration transistor. The coupling capacitor Cout blocks DC by providing an AC path from the collector to the tank circuit. So how does Colpitt's oscillator work? Whenever power supply is switched on, the capacitor C1 and C2 in the circuit start charging, and after the capacitor gets fully charged, the capacitor starts discharging through the inductor L1 in the circuit, causing damped harmonic oscillations in the tank circuit. Thus, an AC voltage is produced across C1 and C2 by the oscillatory current in the tank circuit, while these capacitors get fully discharged and electrostatic energy stored in the capacitor gets transferred in the form of magnetic flux to the inductor, and thus inductor gets charged. Similarly, when the inductor starts discharging, the capacitor starts charging again, and this process of energy charging and discharging capacitor and inductor continues, causing and generation of oscillations, and the frequency of these oscillations can be determined by using the resonant frequency of the tank circuit, consisting of inductor and capacitors. This tank circuit is considered as the energy reservoir or energy stored. This is because of frequent energy charging and discharging of the inductor, capacitor. That part of LC network forming the tank circuit. The continuous undamped oscillations can be obtained from the Barkhausen criterion for sustained oscillations. The total phase shift must be 3600 or 0. In the above circuit, in the circuit a while ago, a two capacitor C1 and C2 are center tapped and grounded. The voltage across capacitor C2 is 1800 with the voltage across capacitor C1. The common emitter transistor produces 1800 phase shift between the input and output voltage. Thus, the Barkhausen criterion, we can get undamped continuous oscillations. The formula for resonant frequency is equal to 1 over 2 pi square root L1 times C, when C is the equivalent of capacitance of series combination of C1 and C2 of the tank circuit. It is given as C1 parallel to C2, and L1 represents the self-inductance of the coil. In this part, we have the applications of Colpitt's oscillator. It is used for generation of sinusoidal output signal with very high frequencies. The Colpitt's oscillator using SAW device can be used as a different type of sensor, such as temperature sensor, as the device used in this circuit is highly sensitive to perturbation. It senses directly from its surface. It is frequently used for the applications in which very wide range of frequencies are involved. Used for applications in which undamped and continuous oscillations are desired for functioning. The oscillator is preferred in situations where it is intended to withstand high and low temperatures frequently. The combination of this oscillator with some devices can be used to achieve great temperature stability and high frequency. It is used for the development of mobile and radio communication. And lastly, it has many applications used for the commercial purposes.
Colpitt's oscillator uses a capacitive voltage divider network as its feedback source. Two capacitors 1 and 2, are placed across a single common inductor as shown. Then, the capacitor 1 and 2 and inductor form the tuned tank circuit with the condition for oscillations being X C1 plus X C2 is equal to XL. The same as for the Hartley oscillator circuit. The advantage of this type of circuit of capacitive circuit configuration is that with less self and mutual inductance within the tank circuit, frequency stability of the oscillator is moved along a more simple design. This is because the capacitors provide a low reactance path for the high frequency signal, and thus the output signal in the high frequency domain will be more sinusoidal. In calculating the frequency response of the oscillating is using the formula 1 over 2 pi square root of inductance times the total capacitance, where total capacitance is the product of C1 and C2 over the sum of C1 and C2.
For conducting the group's prototype, we use a simulator tool, LTSpice, for simulating our own example of Colpitt's oscillator. To start off, the components that we'll be using to create a functioning circuit for the simulation will be the following: 1 bipolar transistor, NPN junction, 3 resistors with a value of 2.5 kiloohms and 5 kiloohms, 5 capacitors with a value of 5 nanofarads and 25 nanofarads, 1 inductor with a value of 1.2 Hz, 1 voltage source with a sine value of 1.2 volts for the voltage amplitude and 100 Hz for the frequency, and the ground. For running the simulation, the settings was into the following preferences: transient analysis that will stop at 1 second. The time that will save its data will be at 10 milliseconds at the maximum time step of 100 milliseconds. The waveform shows sine wave due to the response to the circuit. It adheres to the theory of Colpitt's oscillator.